So I would probably do this, or you could take it up to 0.7 and 1500. I mean, that'll still be decently close. You took this up and took that down.
What about
Right.
going to 0.5 and then going to 1600 on the other way?
Yeah, you could do 0.5, in which case I would probably go up to 2000 then,
2000.
roughly. If that's a decent big step down, unless you want to go decent big step up. The nice thing is, what can you always do? What is 0.63 times 1523? What is that? Who has their calculators out? What is 0.63 times 1523?
959.40.
Exactly, see? And that, if you made this 0.5 times 2000, what's half of 2000?
1000.
And that's pretty damn close to what it's supposed to be. But if you made this 0.5 and, I don't know, 1600, that's getting kind of far away from what it's supposed to be, right?
Well, it's 800. It's 800. So it was what, 900 and something, right?
955, yeah, it's still decently close, yeah. What I desperately want you guys to get is the idea behind what we're doing. If you can't quite get some of the specific problems to work quite right, and we're not used to this whole idea. Going from 0.63 to 1 is huge. If you had a 63% chance to live after a surgery, and the doc says, no, I was wrong, it's actually a 100% chance. That's a huge change, right? So that is actually a big change. If I go from 0.63 to 1, so I better make a decently large change here. So I don't want to go to 1500, I'd at least want to go to 1000. And that ends up being pretty good. That's what I mean, that's that relative change. I mean, it's a small number, so any change is going to be kind of huge relatively. The main thing I want you to get down is just the rules. When you multiply, they got to go different directions. When you divide, they got to go the same direction. You can break the rule, but you better tell me, is it high or low now? Beyond that, you guys can do whatever makes sense.
If you say that again, if you multiply, you what?
If you multiply, you go different ways, right? When it goes up, the other's got to go down. When you divide, they better go the same way. And we know that. What is 3 over 6 equal to? 1 over 2. Didn't they both go down?
Yeah.
To keep it the same, right?
Yeah.
We know that already. We're just making it a little more formal now, right?
What if you increase?
Well, yeah, if you increase, what is 1/2 equal to? It's equal to 4 over 8, right? You still have to take them both up to keep the ratio the same. Okay. No.
No.
For the other one, I did 0.18 for the 10, so I can do 1500.
So you took this to go where?
I did 0.18.
So if you're going to take this, I agree. If you make this go down, if you make this go to 1500, you want to take this and make it go up. You can make it nice and round then, 0.20.
Oh, okay.
I did 20 and 60.
Oh, now if you, again, if you take this up, this one better go. Yeah. You guys get that? That's what I desperately want you to get right now. If I'm multiplying, they better go opposite directions, or else I'm overestimating, right? If they're dividing, they better go the same direction. You can break the rules sometimes if it makes sense, but then you better tell me, is it low or high? Let's only do this one a different way. I mean, here you get, watch this, is kind of cool. If I move this decimal over once, I move this one back once. 300. Did somebody do this one a different way?
I did breaking the rules, 20
Oh, I see.
and 16. I got
You took this one to 2,000?
220.
Oh, took this down to 1,000. Too much, but I still would be, at least you're following the rule, right? Because the idea of how much to change it by is weird, and I understand that. So as long as you're following the rule, it's okay. And always double check yourself. What is 18% of 1576? Do it and see how close you got. If you got pretty far away, oh crap, I took something too far.
Oh, I did 20%, 16,000. I got 320, which is almost close to 10.
Yeah, it's pretty close, but still, it's a
Highest
high
one.
estimate.
Yeah,
Yeah,
but
exactly.
the highest estimate.
If you could also go down, you could make this 15% of 1,600, right? If I take this one down, I can go up on this one. Now that's not the easiest thing to do unless you do it the way we did the tip. All right, 10% of that is 160, half of that is 80, add them together. Still get decently close. Okay, cool. Maybe. What about where are we at here? So that's number 10. So around 300 should be what you get, around 300 or so. What about 17?
We're up to 60 down to 50.
So what'd you do? What's the operation you have to do?
60 divided by 12.
Multiply, right?
Right.
Oh, definitely. 57 miles per hour, and I go for 3.2 hours. I'm gonna multiply, right?
Yeah.
Yes.
So do 60 times 3.
So if you take that one, go up. You can take that one down. I love it, right? That's exactly the idea. Sometimes the numbers get uglier. Do the best you can. That's all I'm saying. Show me what you're doing. Show me what you're trying, and do the best you can. Cool. So here you get
90. Oh,
180.
sorry.
That's
180.
right.
Sorry.
And then again, just to double check yourself, you actually do what it is, and hope the idea gets kind of close. Okay, cool.
Does this apply to like addition and subtraction?
Beautiful, right? Addition, subtraction is sort of like multiplying and dividing. It's a little bit easier though. I don't think I gave you probably that. What's the last one I did? 12?
Yeah, so
Yeah.
Yeah, I said division 1, 296.3 divided by 0.0096. Now this one you don't have to break any rules, because what does that 296 want to become?
200.
300, right? So I can go take that one up, so the bottom better go up also, right?
So up to
Not 1,
0.01.
0.01.
zero.
If you really want to see it, 0.0096 is close to 0.0100, isn't it?
Yeah,
It's nowhere near 10,000 or whatever. I can't take it all the way up to 1. That's huge. I know when you start talking about small numbers, you're like, those are not far apart. Yeah, they're relatively, they are damn far apart. If it used to cost a cent and now it costs $1, aren't you going to be upset? And like, what's big is only $1? No, it's relative. Oh my God, it's a cent, dude. What the hell? Now it costs $1? What the hell's up with you, right? So that's way too big of a change. It should be 0.01 to take it up. That's the next thing up from this.
So
Now here's the cool thing again. If you move the bottom how many places over?
So you got
Twice. Move the top over twice.
It's 30,000.
Why you do
30,000.
those twice?
Because again, how far, how many places was this away from being a whole number?
Oh, that's just if you don't use a calculator.
Exactly.
Oh, well. maybe.
But again, I'm trying to show you what you would do and why does it make sense? Because I can multiply top and bottom by 100. Wouldn't that make that decimal go over twice? Now, of course, if you do it in the calculator, great.
That's what I'm gonna do.
Nothing wrong with that really, but you should be able to do most of this stuff in your head, is my hope. Yeah, okay. And I know some of us it's easier, some of us it's harder, and I don't require you to show me somehow doing it in your head. So if you do that in the calculator, I'm not going to know. So that's fine. As long as you show me this step here, that's what I need to see. Okay, cool. So let's talk about like an adding and a subtracting problem. And I think it's time for our field trip.
Just a quick question. For number 17, we could have wrote it. We could have wrote it. We could have switched the numbers, right? Like this is like if you put it first and stuff. That one.
Number 17,
Yeah.
here?
It didn't matter how I wrote the number.
No, yeah, you can multiply whatever order you want to. Yeah. So if I'm adding, for example, if I had like a 181.78 plus 71.9872. If I want to estimate that, if I make this become 200, what do you think that has to do at the same time? Go down. It only makes sense. If I'm making this bigger, I better make that smaller, so overall it comes out. So that's a lot like multiplying, really, right? So if I make this 200 plus 50, adding's a little easier though. That went up by about 20. That can go down by about 20. Do you guys see that? Adding is a hell of a lot easier than multiplying when estimating, because I took that one up by about 20. So if I take that one down by about 20, overall it's going to be about what it is.
And we can do that in mostly all the adding.
All the adding is should work like this, right? If you take parts of it up, you better take parts of it down.
But the same number that I took down, take up.
Yes, cool, exactly.
could you just do 182 plus 70?
Yeah, I mean, that, again, that's not a difficult one to add, but you want to try to make it as round as you can, really.
So 70 wouldn't be wrong.
No, what she did was she didn't change this by much. She made this 182 plus 70.
Oh, okay.
But we changed this one by a lot, we better change that one by a lot, all right? Now, what do you think you have to do when you subtract? Like, what do you want to say, 191.4 minus 83.98. What do you think you have to do there? If I take this one
150.
to 200, you gotta take the other one up also, it's like division. Because, how far apart are 9 and 6? 3. To make it 3 apart still, if I go up to 10, this one better go up to 7. Now it's still 3 apart, isn't it? So to make a difference the same, they have to both go the same way. To make an addition the same, they have to go different ways, so they don't overestimate or underestimate, right? So here, if I make that one go up to 200, that one better also go up to 90, sure. See, that's not too bad. Is that cool?
Yeah.
So adding, subtracting normally makes a lot more common sense with what's going on. Multiplying, dividing, though, they really are kind of like the same thing in a way. Multiplying is like adding, they have to go different ways. Dividing is like subtracting, they have to go the same way.
Anything power of 10? I mean, is there a rule?
The nice thing with adding and subtracting is the rule is very simple. I took this one up by 20, I took that one up by, down by 20. I took this one up by about 10, I took that one up by about 10. Was it exactly 10? No, why not? Because I want it to be a round number, right? Up by about 10. You don't have to be perfect. Okay. I think that's the key phrase. You do not have to be perfect in this section. What you must show me, though, is some kind of estimation. Don't give me the answer. I want to see the estimated answer, right, in your work. All right, so here's what we're going to do on this field trip. We're not going to come back to the classroom, so you can just take everything with you. We're going to go upstairs in the tech ball, then down to the Math Study Center, and then over to my office, and then you're free.